So, we're skipping 5.6 today. We're coming back to it tomorrow. Today we are solving rational equations with rational expressions. So instead of simplifying like you did on the quiz that you just took, we're actually going to be solving. So we have a couple steps. First, you want to multiply both sides of the equation. So you want to make sure you multiply both sides by the LCD. And the whole goal of that is to get rid of the fractions. Since we're multiplying both sides, you will distribute and reduce if you can, and then solve like normal. Alright, example 1, we have 1/2 plus 2 over x equals 1. We want to solve for x. Now, what's the problem here? X is not in the numerator. Where is it? It's in the denominator. So we want to get rid of the fractions here, because even though fractions are our friends, we don't like them in these kinds of problems. So we're trying to get rid of the fractions. So, step 1 tells us to multiply both sides by the LCD. So what would the LCD be here in this problem? 2x. So multiply both sides by 2x. Why both sides? Yep, good. Whatever you do to one side, you have to do to the other. Okay. So we're multiplying both sides by 2x. Now, what do you guys notice on the left-hand side? It's also in step 2. What can I do on the left-hand side? Distribute. So we're going to distribute 2x to both terms. So I want to rewrite it first right now. So this is going to be 2x times 1/2 plus 2x times 2 over x. Is everybody okay with that? Okay. And then 1 times 2x gives me 2x. Now we're still in step 2, which says that we can reduce. 2x is the same as 2x over 1, so we can cross-reduce here. Where can I cross-reduce? 1/2 reduces with the 2's. And then we have to multiply what's left over. X times 1 gives me x. Plus, look at the second one, what reduces there? The x's. So 2 times 2 gives me 4 equals 2x. Does this look like something that we know how to do? Yes, it does. We want to solve this. Okay, now I have 1x on the left and 2x's on the right. So in order to get all x's to the same side, I'm going to subtract x from both sides. And that gives me 4 equals 2x minus 1x? 1x. So x equals 4. Or 4 equals x. Same thing. All I did was subtract 2x minus 1x. So example 2, we have 15 over x minus 3 over 3 equals 2. I know that 3 over 3 reduces to 1. Okay, but leave it like it is for right now. Okay, what is the LCD here? 3x. So, remember, in the previous problem, we multiplied the entire left-hand side by the LCD and then distributed, which means every single term got multiplied by the LCD. So, is everybody okay if I just do this? 3x, this one's a 3x, and that one's a 3x. Is everybody okay with that?
It's 3x because...
So then what reduces here? 3x over... 3x and x, we have to cross-reduce only. So what reduces? The x's. So we're left with 3 times 15. What's 3 times 15 give me? 45. We also have a 3 and a 3x, which we can reduce. What reduces there? 3. So we're left with minus 3 times x, which gives me 3x. Equals 2 times 3x. 6x. You have to remember the right-hand side as well. Every single term gets multiplied by the LCD. Every single term. Okay, to solve this, let me pull a stick. What would I do? Who is 26?
Oh my god. What do we do next?
Yep.
Next,
We have 45 minus 3x equals 6x.
oh, sorry.
Okay, how?
We put
Okay, get both x's on one side. So which one will you move? Okay, so how do I move 3x? There we go. Add 3x. So everybody add 3x. Because negative 3x plus 3x gives me 0. So that gives me 45 equals 9x. And then my next step is what? 22. Andrew, next step. Divide by? By what? 9. Good. So that gives me x equals 5. Okay, example 3. 4 over x minus 3 over 5 equals 2 over 5. What I want you guys to do, you don't have to do the whole problem. I just want you to multiply by the LCD. So I need you to figure out what the LCD is, multiply, and reduce. Alright, what was the LCD? That's all I want to know right now. What was the LCD? Who's 21?
You never called me.
Jose, what was the LCD? Okay, so 5x. So multiply everything by 5x. So that's 5x. This guy's 5x. And this guy is 5x. So we are multiplying by 5 times. Okay. So 5x and x. What reduces there, guys? The x is... No, not always. 5 times 4 gives me 20. So you have to multiply what's left over. And remember, you can only reduce one top for one bottom. You cannot reduce tops. That's multiplication. Okay, so 5 times 4 gives me 20 minus, look at here, I have 5 and 5x. What reduces there?
5.
The 5. So I'm left with 3 times x. So that gives me 3x equals, the 5's reduced. So we're just left with 3 times x. Okay, and then what reduces on the right-hand side? The 5. So I'm left with 2 times x, which gives me 2x. Okay, next step to solving. This is a two-step equation. What do I do first? Who's in 13? Genevieve. Genevieve.
You just wasted our time there by sitting there.
Yes, I add 3x to both sides. So that gives me 20 equals 5x. And then to solve, next step is what? Who is 15? Aaron, next step. What? Divide by what?
5x.
Not 5x,
5.
just 5. So that gives me x equals 4. So for example 4, I have 1/2 plus 2 over x equals 2 over 3. How many denominators am I working with this time? 3 of them. A 2, an x, and a 3. So what would the LCD be? 6x. I need something that 2 goes into, I need something that x goes into, and I need something that 3 goes into.
But then how come it wasn't like that for example 3?
Because example 3, both of them had 5. So multiply everything by 6x. So let's look at reducing. On the left, 6x and 1/2. What cross reduces there? Who is 39? Celia, what reduces? We're just looking here. 6 and 2. 2 goes into 2 once and 2 goes into 6. 3 times. So I have a 3x times 1, guys. What does that give me? 3x. 2 over x times 6 over x, or times 6x. What does that give me? Who is 16? Okay, Jer, what reduces here? The x is reduced. So that leaves me with 2 times 6, which is plus 12, equals 3 and 6. What reduces there? Who's 4? Antonio.
3.
The 3. 3 goes into 6 how many times? 2. So we are left with 2 times 2x, which is 4x. You only reduce the denominator with what you multiplied by. The denominator should disappear every time. So every single time you should be getting a regular two-step equation.
If the denominator...
So then to solve this, we subtract 3x from both sides. So I get 12 equals x, and I'm done.
Ooh, I got it right.
So example 5. 4 over x plus 5 over 2x equals 1 over 4.
So do we have...
Zach.
4x.
Okay, 4x. Anybody get anything different? Marcus. 2x. Anybody get anything besides those? 8x. Anything else? 10x? Really? 4 doesn't go into 10. Anything else? Did anybody get 4x squared? Or 8x squared? Anybody get either of those? Okay. That's exactly right. Jocelyn said it perfectly. There can't be an x squared because each of these have only one x. We don't have to multiply all the denominators together. We're trying to find the smallest one that everything goes into. So the x squareds, we don't need them because each of these only have one x. So now let's think about it. Of all of what is the smallest thing that each of them go into?
4x.
Okay, let's work our way backwards, guys. 8x. Does 2x go into 8x? Yeah. Does 4 go into 8x? Yes. Is it the smallest one? No. So now I'm hearing a lot of 2x, so let's try 2x. Does 2x go into 8x?
Yes.
Or 2x. Does 4 go into 2x?
No.
No. 4 does not go into 2. So what is our answer? 4x. Okay, so multiply everything by 4x. Turn around, please.
Wait, I have a question.
Okay, guys, look here. 4x and x, what cancels there? The x's. So we're left with 4 times 4, which gives me 16. The 4 and 4 do not cancel because they are both numerators. So you have to multiply them. Okay, 2x and 4x, what reduces there? The x's cancel, and 2 and 4 reduces to what? To 2. So I'm left with 5 times 2, which gives me plus 10, equals 4 and 4x. What reduces there? 4. So 1 times x is x. So x is equal to what? 26.
Oh, it's x.